Chapter 1, Section 5, Solving Ratio Problems. For this chapter, or this lesson, students are going to solve real-world problems involving ratios. This is where the rubber meets the road, and you're going to find the more you understand ratios, the more you're going to use them. In fact, my youngest son, uses ratios to calculate how much money we owe him every time he gasses up his tank, because we pay for any driving he would do for us, and he pays for any driving he would do for him, like going to hang out with friends, going to work, and going out on a date. So, first things first, definitions. You did gain one new definition for this lesson. That's going to be equivalent fractions. Equivalent fractions name the same comparison. A good example would be 1/2 and 2/4. 1/2 and 2/4 represent the same amount of item. For example, 1/2 of a pizza is the same thing as 2/4 of the pizza. Equivalent fractions. And with that, we are ready to start on this new lesson. I think this one has the most resources we have seen so far at 11, but it's only supposed to take 90 minutes total to do the lesson, so this is supposed to be a 2-day lesson as well, just like all the others I think we've done so far in this chapter. Launch the lesson. Have you ever conducted a survey with your friends or family? A survey can be used to collect information about a person's likes or interests. Once the data is collected, you can compare the data using ratios. Sometimes those ratios can be used to make predictions about larger groups of people. After taking a survey of your class, you learned that about 2/3 of the students in your class prefer chocolate ice cream over vanilla ice cream. How do you think you could use your survey results to predict how many students in your grade level would prefer chocolate ice cream over vanilla ice cream? That's the kind of problems we're talking about here. That's what we're going to be working towards understanding and being able to solve in this lesson. Resource number 2 is about using bar diagrams to solve ratio proportions or problems. Suppose 3 out of 5 randomly selected students at a certain school play sports. There's 525 students at the school. Move through the slides to create a bar diagram to predict how many students play sports. And to do this, I'm going to take and show you a video that they have created on doing exactly what we're talking about.
Draw bar diagrams to solve ratio and rate problems. Enrique can make 10 balloon animals every 5 minutes. At this rate, how many balloon animals can he make in 7 minutes? Use a bar diagram to find the unit rate. Draw a bar to represent the time it takes Enrique to make 10 balloon animals. Label the bar with 10 animals. Divide the bar into 5 equal sections to represent 5 minutes. Divide the number of animals, 10, by the number of sections, 5, to determine the number of animals made every minute. So, Enrique makes 2 balloon animals every minute. Write 2 animals in each section. Now you need to figure out how many balloon animals he can make in 7 minutes. Draw a bar to represent 7 minutes. Label the bar with blank animals. Divide the bar into 7 equal sections to represent 7 minutes. Since the unit rate is the same, label each section with 2 animals. Multiply the number of sections, 7, by the value of each section, 2, to determine the number of balloon animals Enrique can make in 7 minutes. Since 7 times 2 is 14, Enrique can make 14 animals in 7 minutes.
Alright, that's a really well done video to show you how you can use the bar diagram in order to find out a new amount. Now we're going to go and draw our own bar diagram, walking through the slide here. Remember, our original problem said suppose 3 out of 5 randomly selected students at a certain school play sports. There are 525 students in the school, and now we're going to find out how to predict how many students play sports. So we're going to click on the next dot, and on that next dot, they divided it into 5 sections because 3 out of 5 students, so since you got 5 students, they broke it into 5 sections, played or who was interviewed. From here, they're going to take and say, well, how many played sports? 3. How many do not play sports? 5. And they label those portions of the bar. After they label the portions of the bar, then they can take and say, well, we got 525 students in the school, and 3 out of 5 could possibly be playing sports. So what is 3 out of 5 of 525 going to be? Well, if you were to take and divide, and you can see right down here, that's where they did it. They divided 525 by 5, and that is where they got this 105 in each one of those. They used division to find out how big each of those 5 sections were going to be. And then after they found out how big each of those 5 sections were going to be, next thing they did is they multiplied that number, 105, by 3, and by doing that, they found out that approximately 315 students at the school will play sports based off of that survey that they did. For our Think About It section, when you're thinking about the ratio of students who play sports to the total number of students, is it easier to think about a 3 to 5 or 315 to 525? Now, I'm sitting here thinking, 3 to 5 is a lot easier to visualize than 315 out of 525. Next resource. Use bar diagrams to solve ratio problems. 2 out of 3 randomly selected students in Miss Mason's class at Heritage Middle School prefer cats as household pets. Speaking of cats, you can hear Tilly screaming at me. Come on, Tilly. Than any other pet. Now, I think that may not be a terribly accurate survey. I know there's an awful lot of dog people out there. It says there are 750 students at Heritage Middle School. How many students can be expected to prefer cats as a household pet? And here's my Tilly, my screaming demon. She's a terrible annoyance. She's really fat. For Think About It. How do you know what number of students at Heritage Middle School who prefer cats can be expected greater than 375? Okay, so we want to think about it again. What's it asking? How do you know that the number of students is going to be greater than 375? Where did 375 come from anyhow? Well, let me show you. We're going to put Tilly down and take a screenshot. So I've got my screenshot going here, and now we're going to get our marker. Woo! And we call that wee moments. We're going to get our marker going. And with our marker, I'm going to take and we're going to look at this problem. We want to know where on earth that 375 came from. Well, the 375 came from dividing 750 by 2. If we were to do our long division here, 750 divided by 2, 2 goes into 7 3 times. 3 times 2 is 6. Bring down your 5. I'm sorry, not bring down your 5. 7 minus 6 is 1. Now we're going to bring down the 5. 2 goes into 15 7 times, which is 14. 1 left over. Bring down your 0. 2 goes into 10 5 times, which is 10 with nothing left over. That is where the 375 they're talking about comes from. So, if you think about it, 375 out of 750 would simplify to be 1/2, 1 out of 2. They are wanting to know read your question again, how do you know the number of students at Heritage Middle School who prefer cats can be expected to be greater than 375? The answer to that is because they are expecting 2 out of 3 to be people who prefer cats. 2 out of 3 is greater than 1/2. 2/3 is greater than 1/2. That is how they would expect it to be a number greater than 375. Next, we're going to move through the slides to see how the bar diagram can be used to solve the problem. So, just like we did last time, we're going to cut this up into, instead of 5 sections, we're going to cut it up into 3 sections. And of those 3 sections, 2 of them preferred cats, 1 of them did not prefer cats. And we labeled each one of the groups. We shaded the preferred cats part. We did not shade the do not prefer cats part. So now we've got a bar graph to start with. From here, we're going to break it down even further and recognize that there's 750 students. Out of the 750 students, they want to know how many do you think would prefer cats. I'm going to want you to pause the recording right now and you go ahead and calculate the rest of that out on your own, see what you come up with. So, what are we going to do? Well, first we need to take and figure out how much each one of these sections are. To do that, we're going to take a screenshot and solve the problem. So I'm going to take now, instead of clearing my screen, I'm just going to slide it off to the side here, and we're going to paste our new section in right here. Now, think about what they're asking. They're asking us to divide 750 students into 3 categories. So we got some more long division to work out here. 750 divided by 3. 3 goes into 7 2 times. 2 times 3 is 6. That's going to leave us 1. Bring down your 5. Next 3 goes into 15 4 times. 4 times 3 is 12. 3 left over. Bring down your 0. And 3 goes into 30. I think I goofed. What did I do wrong? I did go wrong. Let's go back here. I totally goofed here. So instead of 4, it should be 5 times. 5 times 3 is going to be 15, which leaves nothing left over. But we still have this 0 to contend with. That 0 is going to come down to be right here. And we're going to say 3 goes into 0 how many times? 0 times, because you had an invisible decimal here. And we've got to work it all the way to the decimal. So each one of these categories is going to be 250. And we can see that laid out here in our next slide, where they've got your 250 in each category. And for now, here we're going to go on to the next part to figure out, all right, how many students can they expect to prefer cats? So, give it a second to prepare itself. You take a minute and pause the screen and solve that, put your answer in, and check your answer. Alright, so what are we going to do? We've got 250 times 2. We're going to go back to our screen over here and do 250 times 2. When we do that, 2 times 0 is 0. 2 times 5 is 10. Carry the 1. 2 times 2 is 4. Plus 1 is 5. So the answer we need to put in our box here is going to be 500. Check that answer, and we did well. Moving on to slide number 4 of this set. How can you use a ratio reasoning to check your solution? Well, I guess we could take and just ask ourselves, does that make sense? Does two-thirds of 750 students, does that sound about 500? I think so. And then they have their check section here, which of course doesn't work. So we're going to move on to resource number 4. For this resource, I want you all to pause your video and solve that problem. Now I want to point out that there's a need help section here, and you will have access to this in your book as well, your online book. Let's see what happens when we click it. So we click it, and now you have a suggestion. Make a bar diagram. Since each section of the bar diagram represents 10 students, you can multiply 17 by 10 to find the number of students expected to have a dog. We're going to hide that. You pause this recording and you work the problem. Alright, once again, we're going to clear off our slate here, move to a new zone, paste in our problem, and we're going to work through this. It says in the survey, let me find my pen back, a survey of Miss Thompson's class shows that out of 30 students, 17 of them have a dog. So we've got 17 out of 30 have a dog. Now let's go back and look at that tip that they have there again, because it was a really nice tip. What do they suggest you do? They suggest you knock it down into sections that represent 10 students and multiply by the 17 by 10. I'm not sure that that's real clear, so let's think about it for a second. Alright, after going back and looking at the problem, I realized that they gave us a really bad example. You see, what they told us was that each section of the bar graph was going to represent 10 students, and that's not going to be accurate because it doesn't make sense. What they actually should have said, and let me get my pen working here, is that each section should have been 30 students. So what we're going to do is we're going to make a big bar diagram here, and we're going to divide that bar diagram into 10 sections. So I got my middle section here, which will be half. That's going to be your 5 mark. And then we got to break it down to where there's approximately 5 sections in each part, and then 5 sections in the second half right here. And each one of those sections is going to have 30 students in it. Okay? So you got 30 students in each one, and of those 30 students, when you multiply that number times 10, you're going to end up getting your 300 students. Therefore, you could take and say, well, what is 17 out of 30 when you compared it to 300? All you have to do now is do what they suggested and say, all right, well, let's multiply. Since I had to multiply 30 by 10 to get to the 300 that we had here, I'm going to multiply 17 by 10 as well. We're going to look at that. In fact, we don't even really need anything to do it, because when you multiply any number by 10, all you have to do is put a 0 on the end of it to find out your answer is going to be 170. And you could actually break that down on the bar graph too, to say that you got 30, 60, 90, 120, 150. That would be 180. So you would have about this section right here that are going to like cats over dogs. Incidentally, my wife just messaged me wanting to know if I wanted a new dog. We shall see what happens. I already have a name picked out. So we're going to go back here, and we're going to put in our number, 170. We're going to check our answer, and once again, we did score. I'm going to stop this video. This will be part 1. We'll come back shortly with part 2.